Hello student, welcome back to the YouTube channel. In this video we will continue with the 2-mark questions from the chapter real number. Look at the question. We have to prove that root 3 plus 5 is irrational number. To prove that root 3 plus 5 is an irrational, first we need to assume it as a rational number. Write the statement. Let us assume root 3 plus 5 as rational number. Root 3 plus 5 can be expressed as P by Q, where PQ are co-prime. Co-prime means both the numbers should have one as a common factor. P and Q are co-prime and Q not equal to 0. Now shift this 5 to RHS. We will get root 3 equals P by Q minus 5. Since denominators are different, take an LCM. We can write it as P into 1, P minus 5 into Q. 5Q by multiply this to Q into 1, Q. Now you can observe here, LHS is an irrational number. Right? LHS is an irrational number, whereas RHS is rational number. We got RHS as a rational number and LHS as an irrational number. LHS is not equal to RHS. Since we have got one as irrational and one as rational number, both are not equal. So this contradiction occurs due to our wrong assumption. You need to write the statement. This contradiction occurs due to our wrong statement. Therefore, root 3 plus 5 is an irrational number. The same steps you can follow for all these questions. That is 2 plus root 5, 6 plus root 2, root 5 minus 7, 5 minus root 3, 3 plus 2 root 5. I will solve this question 3 plus 2 root 5. Follow the same steps. We need to follow 3 plus 2 root 5 as an irrational number. So what's going to be the first step? We need to assume it as an rational. That is 3 plus 2 root 5 as a rational number. So 3 plus 2 root 5 equals P by Q. P and Q are co-prime and Q not equal to 0. First we need to shift 3 to the RHS. 2 root 5 equals P by Q minus 3. Denominators are different. 2 root 5 is equal to P minus 3Q by Q. Root 5 equals P minus 3Q divided by 2 is in multiplication. If we send, it will come to the division denominator part. Now LHS is irrational number and RHS is rational. So LHS not equal to RHS. After this, conclude the sum by writing the statement. This contradiction occurs due to our wrong assumption. Therefore, 3 plus 2 root 5 is an irrational number. Look at the next question. There is a circular path around a sports field. A takes 18 minutes to drive one round of the field, while B takes 24 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction, after how many minutes will they meet again at the starting point? Let's understand the question. So according to question, there is an circular field and there are two persons, that is A and B. So A is taking 18 minutes to complete the one round, whereas B takes 24 minutes to complete the round. And if they start at the same point and if they go in the same direction, after how many minutes both the person A and B will be meeting at the starting point? To find this, we need to find the LCM of both the number, that is LCM of 18 and 24. 18 can be represented as 2 into 3 into 3, that is 2 into 3 power 2. Whereas 24 can be written as 2 into 2 into 2 into 3, that is 2 power 3 into 3. To find the LCM, consider a number with the highest power. For a 3 highest power is 2, that is 3 square is 9. For 2 highest power is 3. 3 cube is 8. 9 8s are 72, which means they both will meet at the starting point after 72 minutes of starting the journey. Next, according to fundamental theorem of arithmetic, already we have seen in the 1 mark question. So according to the fundamental theorem of arithmetic, if 40 is equal to x power y into z, then we need to find the value of x, y and z. 40 can be written as 2 20s are, next 2 10s are, 2 5s are. Now 40 is equal to 2 power 3 into 5. Now compare with this, that is 40 equals x power of y into z. If you compare, the value of x is 2, value of y is 3 and value of z is 5. It is the value of x, y and z. Look at the next question. The length and breadth of a rectangular field are 147 meter and 56 meter respectively. Calculate the maximum length of the rod that can be used to measure both length and breadth exactly. How many times this rod has to be used to measure the length of this field? Let us understand the question. They are given the length and breadth of a rectangular field. Okay, length is 147 meter and breadth is 56 meters. So the length and breadth is given. We need to calculate the length of the rod which measures both length and breadth exactly. For example, if we start measuring from here and if we go around the rectangular field and if we end at the same point, okay, it should measure exactly. So we have to find the rod with a maximum length, and also they have given to find how many times it has to be used to measure the length, that is 147 meter. To measure this length, how many times we need to use that rod? To find, we need to calculate the HCF of 147 and 56. 147 can be represented as 3 into 7 into 7 and 56 as 2 into 2 into 2 into 7. The only common factor is 7. Therefore, the HCF of 147 and 56 is 7. The maximum length of rod is 7 meter. If we use 7 meter rod, we can measure the length and breadth of the rectangular field exactly. Only to measure the length, we need to use rod 21 times. So number of times this rod fits into the length is, we need to divide 147 by 7, will get 21. A sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in such a way that each stack has the same number of burfis and they take up the least area of the tray. What is the number of burfis that can be placed in each stack for this purpose? According to the given question, there are 420 kaju burfis are there, 130 badam burfis are there. We need to arrange them in such a way that each stack should have the same number of burfis. In all the stacks, there should be equal number of burfis, and burfis are used completely. We used to use all the burfis, and area used is minimum. If area should be a minimum, then number of stacks should be maximum. Therefore, we need to find the HCF of the two number, that is 420 and 130. So 420 can be written as 2 into 2 into 3 into 5 into 7, and 130 can be written as 2 into 5 into 13. Now the highest common factor here is 2 and 5. 2 5s are 10. Therefore 10 burfis can be placed in the each stack. Hope you have understood the concept. If you did, don't forget to like, comment and share and subscribe the channel. Thank you.